Okay, so ladies and gentlemen, we have an unknown indicator on page 5. And its Ka is 3.2 times 10 to the negative 5. I've almost got my computer up and running now. I should have done it last night, but I hadn't. I don't know. I was tired, so I went to bed instead. The acid form of this indicator is red. And the base form of the indicator is blue. What is the color of the indicator at its transition point? It will be what color? Purple. Excellent. Red and blue make purple. Do you think you could calculate the pH at which the indicator changes color? Anyone feel like they could do that? Do you want to give it a try? I got one person who thinks they can do it. How about the rest of you?
Yes?
Yes? Okay, do it. So if you've forgotten it all, the pH at which the indicator changes color is called the transition point. What is true at the transition point? Yes? Yeah, so our hydrogen ion concentration at the transition point is equal to our Ka of what? The indicator. What else is true? Just by way of reviewing, what else is true at the transition point? It's purple. What else is equal? We also have the pH is equal to the pKa. Also, And it's not relevant to this question. But it's how we get to hydrogen equals Ka. There's two concentrations that are equal. The acid form of the indicator and the base form of the indicator. Those concentrations are equal. Like I said, that's not really relevant. You could use that first one, pH is equal to pKa. It doesn't really matter. Okay. Now that you got that, you should be able to do the calculation because you know the Ka of the indicator. Yes? There's our Ka. And now how do we find pH? Negative log 3.2 times 10 to the minus 5. What do we get? $4.494?
Huh?
No?
3.2, right?
Let me try it again. 3.2.
No, that's right.
4.495, 4948.
Yeah.
4.49449. How many sig figs? How many sig figs? Two sig figs because we've got that 3.2, so 2 sig figs. So it should be 4.49.
Never mind.
49. Okay? Excellent. What color is the indicator in 1.0 times 10 to the negative 6 molar HCl? Well, what could you figure out from 1.0 times 10 to the negative 6 molar HCl that would be relevant? You could find the concentration of H plus because, of course, this dissociates into H plus and Cl minus because it's a strong acid, and so the concentration of H plus is, oh dear, there we go. So we have the concentration of hydrogen is 1.0 times 10 to the negative 6, and then the pH is 6. So we have a pH of 6, and our pH at the transition point is 4.49. So what color will our indicator be? What does it say? It says that the acid form of this indicator is red. It says the base form of this indicator is blue. And we change from the acid form to the base form at 4.49. Yes? So below 4.49 pH, will we see the acid form or the base form? We'll see the acid form. Above 4.49, we will see the base form. So we have red at pH, below pH 4.49, and we have blue, our base form, above 4.49, and since 6 is above 4.49, the indicator will be blue. And the predominant form of the indicator is IND minus the base form. Yes? Cool. Are we liking this so far? Not too bad, right? Yeah. One last note. As we go down the acid-base indicator chart, the pH at the transition point, what does it do? The pH at the transition point, does it increase or decrease as we go down the chart? It increases. Okay, so the pH at the transition point increases. That means that the pKa, so the pH increases, but the pKa, which is the same as the pH, what does it do? It also increases. Because hydrogen, we good? pKa is the negative log of Ka. If you prefer, yeah? Okay. Now, that means if pKa is increasing, what's happening to the Ka value? It's decreasing. And if the Ka is decreasing, what's happening to the strength of the acids? Strength of acids are decreasing. So therefore, out of all of these indicators, is methyl violet the strongest or weakest weak acid? It's at the top of the chart.
No, it'll be the strongest weak acid.
Yeah, because remember Ka at the top is the highest, because the pKa is the lowest. And remember, those two are the same, right? Down here, the pKa, or sorry, the Ka is the lowest because the pKa is the highest. So down here, the pKa is the highest, and up here, the pKa is the lowest. So methyl violet is the strongest or weakest? It is the strongest weak acid. And indigo carmine, which is way down at the bottom. By the way, if you ever want to name if you ever have a child and you want to name them a really cool name, indigo carmine. Nice, right? Like first name, second name, indigo carmine. Yeah. You'll notice my child is not named indigo carmine. Anyway. Yes. That's okay. No worries. No worries. No worries. All right. And then indigo carmine is the weakest because it's down at the bottom of the weak acids. pKa is lowest, Ka is the highest. pKa is the lowest, Ka is the lowest. All right. We'll leave you to do some of those on your own. Let's see. 5.1b is on page 10. Okay, so we're going to use these acid-base indicators to do things like estimate the pH of a solution. Okay? So we have a solution. We don't know its pH. And it turns phenolphthalein pink. And this solution also turns indigo carmine blue. And just so that we don't have to go scrambling and looking everywhere, I've just put in phenolphthalein and indigo carmine here. So phenolphthalein is pink and indigo carmine is blue. At what color, at what pH does phenolphthalein turn pink? Yeah. So pH 10 or more, it's going to be pink. What color, at what pH is indigo carmine blue?
11.4.
So, from 11.4 and lower. Okay, so basically our pH range is, we know that phenolphthalein is pink above 10, and we know that indigo or carmine is blue below 11.4, so our pH is going to be between 10 and 11.4. Okay, so here's our, it's going to be here. Okay, so this is what we got. And then if we put them both together, let's see, phenolphthalein is pink, must be greater, pH must be greater than 10. Since indigo carmine is blue, pH must be less than 11.4. So the pH range is pH, and this is how you can write it. You write pH in the middle, and you put a less than sign on the one side and a greater than sign on the other side, and you say pH is greater than 10.0 and less than 11.4. Or you could say the pH is 10.0 to 11.4. That's another way of writing the range. Okay? Yes?
Sorry, but like in the middle, like say for indigo carmine 11.1 and 13.0, like within that range, it just could be green again.
Yeah, between 11.4 and 13 it will be green.
Okay, so then, so then basically it can't be like, it just has to be between 10.
Yeah, 10 and 11.4.
If it's like 11.5,
It's going to be green. Yeah. Now, granted, in real life, are our colors that beautifully delineated? No, but, you know, this is all theoretical, right? Now, does it matter that one of the ways of expressing the range includes the 10 and the 11.4, which is this one here, right? This includes the 10 and the 11.4, and the other one excludes them. It says it's bigger than 10 and less than 11.4. No, it does not matter. Do you know why? Because indicators are fairly imprecise in their what you see anyway. Yes? They're not like a really good way of pinpointing your pH. So if you're like somewhere between 10 and 11.4-ish is really what we're looking at. Yes? Yes. If you want the exact, what? If you want the exact pH, use a pH meter. Yeah? All right, and your homework is pages 6 and 7. Page 7 is all just like, yeah.
Oh my gosh, look at that.
Plus, work on your review. Okay?
That's funny.
Because it's pages 6 and 7. I know, right?
Miss Spence, isn't it draining to teach 2, 10, 12 PPs?
No.
Really?
You guys are amazing. Why would it be draining teaching you guys?
Because I teach swimming, right?
Yeah.
And one set I had 3 swimmer 2s classes back to back. And it was so draining,
It does become a bit repetitive.
right?
But I have lunch in between.
Well, I don't.
Right? There was one year where I had 3 blocks of Pen 12. Like, and there was like 2 of them were after lunch and one was like, I can't remember what block it was.
Yeah.
Like by the third one, I was in doing math. I was like, I don't know.
No, literally,
have
that's
have
me.
I said this? I don't know. I can't remember. Have I talked to you?
No, that's me. And then I'm like, and then I call like my second class kids, like my first class kids,
Yeah.
and I'm like, okay, remember we did this last week, and they were like, we never did this, and I'm like, what? Thank you.
That's why having a workbook really helps you to stay really, like on track,
Yeah.
right? And I can see what I've done. But also 2 is not so bad. 3 becomes like
3's like, whoa.
Yeah.
Because I asked Miss Lam as well, and she's like, yeah, it is raining.
yeah. Yeah. I'm okay with it. I'm okay with 2 bars. And then if they're saying
Yeah, see, that's the thing. If it's like swimmer 6 and up, I'm happy. If it's like, oh my gosh, did you have like a class of 4 6-year-old boys before? My friend started crashing out in the snow because she had to teach 4 6-year-old boys.
boys, yes. They are different than girls, very different.
Oh, girls. I have 4 girls and she has 4 boys, same age. And
Yeah.
I'm like, so different?
Yeah. Oh yeah. Oh
It's
yeah.
amazing. It's amazing.
It's stunning how much difference there is. In
No,
just-
there is.
Yeah. And I
And
mean,
the
not
older
that,
kids
not
are
that
like-
there's not people on either end of the bell curve for either of those genders, but
Yeah.
in general,
No, and then the parents complain like, oh, like why are you guys only playing and not doing swimming? Your child doesn't want to learn, so like it's hard for me.
yeah, you can only do so much before they like. "Ah."
So it's like so hard to talk to parents.
Yeah. Hi.
Really excited he lost his iPad and he was under the left yesterday.
Yes, he did. Yes, he did.
Dispense.
You want to take it? Or is he combined with that? Yeah.
Are we allowed to take a full time?
No.
Shame on you.
You should be working.
Sorry, I didn't know that.
That's okay. Don't worry. Because I find people when they get their phone, then they're just like, phone, right? Whereas if I don't let them have their phone, then they're like, I guess I'm at work. I have nothing else to do.
He has class here.
Yeah.
He has class here at church, right?
Yeah.
Yeah, so I'll probably just leave it there and just let him know.
Sure. Yeah. I could actually put it away for him, although I think it's sat here all day. I think it's fine.
Yeah, I left my iPad here for a day.
Honestly, like, I don't know. Maybe I'm wrong, but like, it just feels like.
I did the same thing with the comms. I left
Yeah.
the computer up with my phone.
Yeah.
Walking over each of
I know.
15 minutes. there.
No, no, it's okay. It's Thanos, and he's still here.
Oh, oh.
Yeah, we're good.